The concept of test-driven development is pretty simple. You write the tests, or the agent writes the tests, and then it develops against those tests. The problem with TDD, test-driven development, is pretty much just Goodhart's law. Any metric that becomes a target ceases to become a good metric. In this specific instance, that phenomenon is called spec gaming, specification gaming. You write the tests, and then the agent focuses on the tests, more than it actually focuses on building the feature itself. This is a problem that I first discovered when working with agents, is that writing a checklist of what you expect the test is going to have to implement ends up with spec gaming. I didn't even realize spec gaming was a term. I didn't even realize TDD was a term, because I'm actually not a software engineer. I just build with agents, and I've figured out how to do it in a intelligent way that's not just vibe coding. People call it agentic engineering, I guess. And the solution to it is actually pretty simple, or at least the solution that I made is pretty simple, and it's worked really, really well so far. So you have your normal task, right? Probably decomposed from an existing spec that you generated, but you have your prompt, your task, whatever it is. And if you have some tests that you want to make sure that are included, you include those tests, but you make the emphasis on the feature itself, on all of the things that you want. And then you have the builder agent execute on that task. Once that task is done, you have a separate QA agent look at that same task, and then from that task, generate a list of expectations and tests that it would expect are necessary in order for a successfully completed task. Only once that list of expectations is generated as its own file does the QA agent actually go out and check to see that those expectations for that task were met. And so by inverting the order of test-driven development, you write the tests first, and then you develop against it. You develop first, write tests as though you're going to develop against it, and then validate instead of using the tests to drive. And this pretty much gets you all of the benefits of TDD without any possibility of spec gaming. Once the QA agent, checks to see that all of its expectations are met, it greenlights a task and it moves on to the next stage. But if there are gaps against that checklist stays. It doesn't change, right? It doesn't mutate. And then it writes a new action plan for the next agent, or the previous builder agent. And this new plan is much more specific and much more targeted. And this is designed to specifically remediate all of the gaps, all of the problems with the work that has previously been done by that previous builder agent, which did not see that list of tests. But the QA agent did, because the QA agent is the one that came up with the tests, but it's not the one that implemented. And so in a way, it's also adversarial. You're separating the responsibilities of tests and building, which is something you should be doing anyways. But by inverting the order in which you do it, you're able to patch any of the gaps that may have occurred without the AI over-engineering what it's built specifically to pass those tests. So yeah, it's a pretty simple method, but it is pretty elegant because of how simple it is, in my opinion. And obviously, if you're writing your own tests, then you'll just want to write your own tests, but nobody's writing tests anymore. Anybody who's using AI isn't writing their own tests anymore anyways. They're usually just validating the tests that the AI has generated. So if you're using TDD in your own workflows or anything like that, try this method out. It's pretty easy to implement. It's pretty straightforward. And the specific phrase that I use to talk about this inverted method is called blind expectations, because you're creating the expectations without knowing, or the agent is creating the expectations without knowing what the builder's already done. And only once those expectations have been frozen and set in place does the agent actually go and check what's been built against those expectations. And because LLMs have the ability to check for not just tests, but also, more ambiguous semantic requirements, I called it expectations instead of just tests. Anyways, to caveat this, I'm not a software engineer. I'm just somebody who really likes agentic engineering.